We've looked at its proximal end already. Now let's see the distal end. It's flattened from front to back, with a complicated articular surface and two prominent lumps, the medial epicondyle and the lateral epicondyle. These are major muscle origins, as we'll see. Above each epicondyle is a ridge, the epicondylar ridge. Here's the lateral one. The articular surface is in two parts. The pulley-like trochlea articulates with the ulna. The rounded capitulum articulates with the radius. Now we'll add the radius and the ulna to the picture. The big hollow on the back of the humerus, the olecranon fossa, accommodates the end of the ulna, the olecranon, in full extension. Now let's look at the two forearm bones, the radius and the ulna. They're different in that the ulna is bigger proximally, the radius is bigger distally. They're also different in that the radius rotates, the ulna doesn't. The two bones are held together by two radio-ulnar joints, the proximal and the distal. Forearm rotation happens simultaneously at both these joints. The two bones are also held together along most of their length by the strong but flexible interosseous membrane, which prevents the two bones moving lengthwise relative to each other. Let's look at the proximal ends of the radius and the ulna. We'll look at the ulna first. The main feature of the proximal end of the ulna is this large curved articular surface. The curve that it forms is called the trochlear notch. It articulates with the trochlea of the humerus. The very proximal end of the ulna is the olecranon. The triceps tendon is attached to it. This projection is the coronoid process. Distal to it, this rough area, the ulnar tuberosity, marks the insertion of the brachialis tendon. This small curved surface, the radial notch, is where the head of the radius articulates. This is the head of the radius. This is the neck. The end of the head articulates with the capitulum of the humerus. Its curved side articulates partly with the radial notch of the ulna and partly with the ligament that surrounds it, as we'll see. Just distal to the neck is the radial tuberosity, which is the insertion for the biceps tendon. Now let's look at this unique joint, where two quite different things happen. The humerus articulates with the forearm bones to form the elbow joint, and the forearm bones articulate with each other to form the proximal radio-ulnar joint. Here's the joint, with its loose capsule removed and its ligaments intact. Here's the front of the joint in extension, and here's the back of the joint in flexion. The key structure to understand is this remarkable ligament, which not only holds the radial side of the elbow together, but also holds the rotating head of the radius in place against the ulna. It has two parts. This part is the radial collateral ligament. This part is the annular ligament. We'll take the humerus out of the picture for a minute to get a look at the proximal radio-ulnar joint. Here's the trochlear notch of the ulna. Here's the head of the radius, seen end on. The annular ligament, together with the radial notch of the ulna, provides a perfectly fitting socket for the head of the radius to rotate in. Here's the annular ligament with the radial head removed. It's attached to the edges of the radial notch of the ulna. It's shaped like a shallow cup, wider here than here, to fit the radial head, not just round here, but also under here. So the radial head, while it's free to rotate, is otherwise totally trapped. Now let's go back to the intact elbow joint and see how it's held together by its two collateral ligaments. The radial one arises from the lateral epicondyle. It fans out and becomes continuous with the annular ligament. The two parts of this complex ligament hold the humerus and the radial head securely together. What we see here isn't the edge of the ligament, it's the cut edge of the tendon of origin of a muscle, the supinator, which arises from the ligament. We'll see this shortly. Here's the ulnar collateral ligament. It arises from the medial epicondyle and fans out in a triangle. It's attached to the ulna all along the medial side of the trochlear notch. To complete our picture of the elbow joint, here it is with its capsule intact. The capsule is thin and baggy in front, and also behind, to allow a full range of movement. There's also a very flexible sleeve of joint capsule here, between the annular ligament and the neck of the radius. The elbow joint is stable, that means it stays together, for two reasons, partly because of the strength of the ligaments, which we've seen, and partly because of the shape of the bones. The humerus and the ulna interlock closely and deeply. Their surfaces are curved in two planes, from front to back and from side to side.